Prompt engineering for code isn't a bag of magic words. It's 6 repeatable patterns, and once you see them, you can't unsee them. Watch what happens when I ask a model to, quote, fix my code. It guesses the language, it invents requirements, and it hands back something generic. Now watch the same task written with intent, a role, the exact context, hard constraints, and a request to verify its own work. Same model, completely different output, precise, runnable, and tested. That gap is not luck. It's technique. Here's the thing most people get wrong: they think a better model is the answer. It isn't. The people getting great code out of these tools aren't using secret models, they're using better prompts, built from patterns you can learn in the next 15 minutes. In this video I'll walk you through the 6 patterns senior developers actually use: role, context, constraints, examples, iteration, and verification. Each one on a real coding task, with a concrete before and after you can copy today. Stop fighting the model, and start driving it. By the end, you'll prompt like a senior. Let's get into it. Pattern 1, Role. The single fastest upgrade to any prompt is telling the model who it is and who it's talking to. Look at the vague version on the left, review my code. The model has no idea if you're a beginner who needs hand-holding or a staff engineer who wants terse, high-signal notes. So it hedges. It gives you a bland, everything and nothing answer. Now the engineered version on the right: you are a senior Python code reviewer, your audience is a junior developer, review the function below for correctness, edge cases, and readability, explain each issue in one sentence and show the corrected line. Look at everything that just got pinned down. The role, senior Python reviewer, sets the depth and the vocabulary. The audience, junior developer, sets the tone, so it explains instead of assuming you already know. And that last clause fixes the output format, one sentence per issue, plus the fix. The model now knows exactly what a good answer looks like, so it stops hedging and starts delivering. A role does 3 things: it narrows the tone, it sets the level of depth, and it controls the assumptions the model makes about what you already understand. You're not flattering the model by calling it senior. You're collapsing a huge space of possible answers down to the one you actually want. Here's the concrete difference in practice. The vague prompt gets you a wall of generic advice: add comments, use meaningful names, consider error handling, the kind of feedback that's true for every function ever written and useful for none of them. The role-scoped prompt gets you, line 14, this list comprehension silently swallows a key error. Here's the guarded version. Specific. Actionable. Aimed at your actual code. Whenever an answer comes back too shallow, or too basic, or weirdly over-explained, the first fix is almost always this: give it a sharper role and a specific audience, and watch the output snap into focus. Pattern 2, Context windowing. A model can only reason about what you put in front of it, so the game is giving it exactly the relevant context, and nothing else. There are 2 failure modes here. Give it too little, and it fills the gaps by guessing, wrong versions, wrong assumptions, code that doesn't fit your project. Give it too much, say you paste 500 lines of a file to debug one function, and you dilute its attention across noise it doesn't need. The sweet spot is surgical. Look at the before: my code throws an error, here's the whole file. Now the after: here is the one failing function, here is the exact traceback, the environment is Python 3.12 and pandas 2.2, and the constraint is that the fix must keep the function signature. That's it. Nothing the model needs is missing, and nothing it doesn't need is present. Notice what good context actually includes: the specific code that's involved, the real error message rather than your paraphrase of it, the versions of the language and the libraries, and any hard constraint on the answer. Versions matter more than people think. Pandas 1 and pandas 2 have genuinely different behavior, and the model will happily give you an answer for the wrong one if you don't tell it. And here's a subtle one that bites people constantly: paste the real error text, not your summary of it. The traceback contains the exact exception type, the line number, and the call chain. Throwing away all of that and typing "it says my code has an error" is like calling a doctor and saying "I feel bad." The specifics are the whole diagnosis. So before you hit enter, ask yourself, have I given it the failing piece, the actual error, and the versions, and have I trimmed everything that isn't load-bearing? Trimming is not laziness. Focused context is how you get a focused answer, and it's also how you keep the model from burning its attention on code that has nothing to do with your bug. Pattern 3, Constraints. Left to its own devices, a model wanders. It'll reach for a heavy library, add an explanation you didn't ask for, or quietly rename your function. Constraints are how you fence it in. Here's the vague prompt: write a function to remove duplicates from a list. Perfectly reasonable, and you'll get something that works, maybe. It might use a set and destroy your ordering. It might pull in a dependency you don't want. Now the constrained version: write a Python function, dedup, that removes duplicates while preserving first seen order, no external libraries, it must run in O of n time, it must not mutate the input, and return only the function, no explanation. Every clause closes a door the model would otherwise wander through. And here's the output, clean, and exactly to spec. It keeps a scene set for O of n membership checks, it builds and returns a brand new list so your original is untouched, order preserved, no imports, nothing but the function. Think about constraints in categories. Dependencies, what it's allowed to import. Complexity, the time or space budget. The signature, names and arguments you need kept. The output format, just code, or code plus tests. And style, pure functions, type hints, whatever your codebase demands. You don't have to specify all of them every time. You specify the ones that matter for this task. And notice that last constraint: return only the function, no explanation. That one is pure quality of life. By default the model wraps everything in 3 paragraphs of chatty preamble. When you're pasting code back into an editor, that's just friction you have to delete every single time. One clause stops it. The rule of thumb to take away: every requirement you leave implicit is a requirement the model is free to ignore, so the requirements you actually care about, you say out loud. Pattern 4, Examples, also called few-shot prompting. Sometimes the fastest way to explain what you want is simply to show it. Quick vocabulary first, because these terms come up everywhere. Zero-shot is asking with no examples at all, just the instruction. One-shot is giving a single example. Few-shot is giving several, usually 2 to 5, so the model can lock onto the pattern. For anything with a specific format or a house style, few-shot wins. Here's the classic case: generating a git commit message from a diff. Ask zero-shot, and you'll get a grammatically fine message that completely ignores your team's conventions. So instead, show it. Example 1, a diff that adds a rate limiter to login, and the message you'd write: feat, auth scope, rate limit login attempts. Example 2, a diff that fixes a null check, and its message: fix, util scope, guard parsestate against null input. Now you hand it the third diff, and because it has 2 examples to imitate, it produces: feat, cache scope, add TTL to the session store, matching your conventional commit style exactly, without you ever writing the rules down. That's the power of examples. You demonstrate the pattern instead of describing it, which is usually shorter and always less ambiguous. Reach for it whenever the output has a shape, a commit format, a docstring style, a specific JSON structure, a naming convention. 2 or 3 good examples will beat a paragraph of instructions almost every time, because the model matches what it sees more reliably than what it's told. One practical tip: make your examples cover the tricky cases, not just the easy ones. If your commit style handles a breaking change with an exclamation mark, show an example with a breaking change. The model generalizes from what you give it, so if every example is the simple case is all you'll reliably get. Curate the examples like you'd curate a test suite, a few well-chosen ones that pin down the edges. Pattern 5, Iteration. Here's the mindset shift that separates people who fight the model from people who work with it. The first output is a draft, not a verdict. You don't scrap your prompt and start over, you refine, in conversation, with small targeted follow-ups. Watch. I ask for a function that normalizes a list of numbers into the range 0 to 1. First draft, it takes the max, then loops and divides each element in place. It works, but look closely, it mutates the callers list, which is a nasty surprise in real code. So I don't rewrite the whole prompt. I just say, that mutates the input, make it pure. And it comes back with a clean version that returns a new list via a comprehension and leaves the original untouched. One more follow-up, now handle the empty list case. And it adds the guard, if the list is empty, return an empty list. 3 short turns, each one fixing exactly one thing, and we've gone from a rough draft to something much closer to production. This is faster than trying to write the perfect megaprompt up front, because you get to react to what the model actually did, instead of everything it might do. There's a real skill in the follow-ups, though, and it's this: change one thing at a time. If you fire off make it pure, and handle empties, and add type hints, and optimize it all in one message, and the result is wrong, you have no idea which instruction it fumbled. One change per turn keeps every step verifiable, same discipline as small git commits. And keep the follow-up specific and grounded in what you're looking at, that mutates the input beats please improve this, every time, because the model can act on a precise observation but can only guess at a vague one. But notice something. Even after 3 clean rounds of iteration, there's still a lurking edge case hiding in this code. And spotting that is the whole point of the last pattern. Pattern 6, Verification. This is the one that actually separates seniors from juniors, so please don't skip it. Never trust model output blindly, not because the model is dumb, but because it's confident whether it's right or wrong. It will hand you buggy code in exactly the same calm tone as correct code. So you make verification part of the prompt itself. Take our normalize function from a moment ago. Instead of shipping it, I ask, what inputs would break this function? List the edge cases it does not handle, then write PyTest tests that would catch them. And it finds the bug that was hiding in plain sight. If every number in the list is 0, then the max is 0, and dividing by that max is a division by 0. It crashes. That's a real defect that survived 3 whole rounds of iteration, and 1 verification question surfaced it. Now I add the guard, if the max is 0, return zeros, and then I run the tests it wrote, myself, because that's the other half of this. You verify, and then you actually execute. There are 3 verification moves worth memorizing. 1. Ask it to write tests for its own code, then you run them. 2. Ask it to explain its reasoning step by step, so wrong logic becomes visible. 3. Ask it what inputs would break the code, or what it deliberately did not handle. And a warning on that first one, don't let the same model both write the code and quietly declare it correct with no evidence. Make it produce runnable tests, then you run them, in your environment, against your data. The tests are the artifact you trust, not the reassurance. Juniors paste the output and hope. Seniors assume there's a bug and go hunting for it, and they make the model help with the hunt. Verification is not optional. It's the single pattern that keeps generated code from quietly breaking in production 3 weeks after you shipped it. Let's lock in all 6. 1. Role, tell the model who it is and who it's talking to set depth, tone, and assumptions. 2. Context, give it exactly the relevant code, the real error, and the versions, and trim everything else. 3. Constraints. State the hard requirements, dependencies, complexity, signature, output format, because anything implicit gets ignored. 4. Examples. Show one to a few input-output pairs when the format matters, that's few shot, and it beats describing the rules. 5. Iteration. Treat the first answer as a draft, and refine with small, targeted follow-ups instead of rewriting. 6. Verification. Never trust output blindly, ask for tests, ask for reasoning, ask what breaks, then run it yourself. And here's how they fit together into one reusable skeleton you can keep right by your keyboard. Open with the role. Then the context, code, versions, error. Then the single concrete task. Then your constraints. Then a couple of examples, if the shape matters. And close by asking it to list the edge cases it did not handle, and to write the tests. Role, context, task, constraints, examples, verify. That is not magic words. That's a repeatable process, and it works on any model. If you want the full written breakdown, it's linked in the description, along with a pack of 91 engineered prompts for developers if you'd rather start from proven templates. Now go rewrite your next prompt like a senior.